welcome to another episode of Amiga Retro. Today we will be performing a firmware update on the Dicke Olga 68030 card as well as the boot ROM or the LIDE device. And as you can see, the computer is functioning still, which is a good thing. Fully operational, and the green LEDs over there is the card itself. So what I'm going to need to do is, of course, remove the card and take it over to the PC, and then I will show you a step-by-step process on how to upgrade all of this. So it's going to be a bit of work on the PC, some other camera work, there's going to be back to the computer here. It's going to be kind of here, there, everywhere, but I'll try to keep it as informative and as simple as possible. Yes, the excitement is about to begin. I will see you shortly at the Windows desktop.
Okay, the first thing we need to do before we attempt to flash the card is we need the firmware and associated files. So we shall journey on to the Internet of Things, the World Wide Web, and there's 4 links here I have, and I will leave the links in the description below. But the first thing we need to do to obtain the firmware is to go to the Amiga website and search for the Dicke Olga 030 forum. Once you're there, and I believe you need to register so you can at least post comments. Once that is done, you go to the bottom of the post and you can just type in your request here. Basically something to the effect of, what is the latest firmware? Where can I find the latest firmware? I need some updates, etc., etc. You can also declare interest if you want to buy this card. So here you have a win-win situation. You can ask questions to upgrade the card, or you can actually put yourself into the queue to order this glorious piece of hardware. The next thing we're going to do as well, so this is for the firmware 009 here, which is the latest version. And of course, by the time you ask for it, it might be even newer than that, but that's besides the point. So we're going to go to this link here, and this is for the boot ROM, the LIDE device. Now, I'm kind of hoping this update will fix that cold boot issue I saw with my DVD-ROM, like it only showing up on a warm boot. But if you turn the computer off, back on again, it will not show up until you soft boot, warm boot, whatever you want to call it. You need to reboot the computer for it to show up. So it's going to be interesting to see if this resolved the issue. So right now we have version 40.7 available and a newer version, which is a basically pre-release, basically from the developers themselves. So I'm going to try this version first. If something odd happens, we're going to go to 40.7. So in here, we're going to download the 40.7.adf, which is basically, it's a floppy disk image. You can either use a GoTech drive if you don't have actual floppy disk or a functioning drive. In my case, though, I have 2 of them in my Amiga 2000. So I'm going to use a program called TrackSaver to extract this to a bootable floppy disk. Now the good thing about this is, unlike previously, right here on this card, this is the boot ROM here. So this is what manages all your compact flash cards, MSATA, all that fun stuff, which has the LIDE device on it, right? And what I had to do before is I had to literally take this chip out of the socket here using an extractor, put it into my TL866 programmer. Of course, I had to have an adapter card for that socket to put that onto it. Then I had to program it, and then when I was done that, I had to put it back into here. So the beauty of this is it will let you flash the boot ROM. Don't get it confused with the firmware of the card. This is just for the boot ROM. It will flash the boot ROM to 40.7 inside the Amiga. You just have to boot off the floppy. It runs a script. It does all of it for you, and you don't have to worry about it. You can leave the card right in the computer itself. Now that's a bonus. Now the caveat to this is you need the latest firmware. If you try to run this, nothing horrible happens. It'll just tell you that the firmware version you have has to be 009 or higher. So obviously we need to program the card first, and then we'll attempt to do this after we know everything works. But to program the card, we need a piece of hardware. This is the FTDI chip. Now it's a C232, which is a serial protocol, HM at the end there. And what this does, this is a cheap Xilinx programmer. So it's a USB 2.0 interface, as it says here, high speed. And then, of course, it has all the data and power lines on the end. And one good thing I like about this is they're all color-coded. If I scroll down this document, which I downloaded off of the website via the internet, amazing tool that can be at times, yes. But anyway, as you can see, you have VCC ground and all the data lines in between. But the beauty of this thing is every single output on this is basically color-coded. So they're all unique, so they're all different, and they're color-coded for easy, connection to the circuit, or in our case, the Dicke Olga 68030 card to the JTAG Xilinx header that I'll show you in a bit. And I already have that planned out, but it just makes it easy to organize what pins go where without confusion because they all have different colors. But hardware is here for the programming. Now we need the software to do this. Now this is for Windows, and I'll be using the command prompt. So you just simply have to download the xc3sprog.exe by clicking on this link here, and that will be running from the command prompt. So this is what we need to get ourselves going. So I shall close this here. Excellent. And I shall go into the folder that I have created to make my life much easier. So I basically collated everything to do with the Dicke Olga 68030 card, but in here of interest for this video, we have the firmware folder I created. And we have the LIDE, which is the boot ROM, and then the Xilinx firmware 009. So if we go into this folder, as you can see, I have the 40.7.ADF I downloaded from that site, and I also have the developer version, which is slightly newer than this. And like I said, I'm going to try this first. If I have issues, I'll just go back to the official release instead of the pre-release. Now, these .ROMs are from what I told you earlier. I've actually flashed it. I had to take it off the board, put it in my TL866 programmer, and all that fun stuff. So this is what I used here. But the beauty of these ADFs, you don't have to do it anymore. You can do it right from the Amiga. So that's self-explanatory there. And now we have the Xilinx folder. So here I have the xc3sprog.exe. I always love saying those combination of letters and numbers, but I don't know why. It's almost a tongue twister for me. I have to slow it down to not mess it up. But anyway, we have the downloaded here from that link I showed you previously. So this is the JED file, the firmware for the Dicke Olga card. And you can also see I had 008, which I flashed previously. So I know this works, and it should flash no problem. So we've got this here. So we've got the programmer, we've got the flash files, and as you can see, I also made a command.txt file. Now, simply what this is, it's a list of commands that I can give the programmer. So right now, you see I have the xc3sprog.exe program with all of its arguments, and then, of course, right here, you can see we have the JED file that I showed you previously. You can also see I've used this to flash my TF1260, my Terrible Fire 1260 card. It too has the Xilinx chips on it, which you can program rather easily with this piece of hardware, the FTDI programmer. So not too bad. So basically the awesome part of this is now that it's in here, that I just put this in a text file, I can copy and paste this in the Windows command prompt, and away we go. And I will show that later in the video. Excellent. So the only thing we have left is something on some instructions on how to actually hook the the programmer up to the card. So here we go. I made this image in paint.exe. And yeah, there we go. The beauty of the card here, this right here, is the JTAG Xilinx. So it's the Xilinx JTAG programming port. But what's really nice is they have silkscreened all the required connections. So basically the data lines and the voltage. So I've took the liberty of color coding everything that's on here with the FTDI programmer. So the TCK signal is orange. The ground is black. TDO is green, 5 volts. As you notice, I didn't connect the 5 volts because the 5 volts on this card will be connected to a floppy-like connector on the board itself from a separate power supply. That way I don't have to lug my 685-pound Amiga 2000 brute into near my computer to program it and power it on. So I'll be removing the card to do this, and I will show you that, of course, soon. So we have the TDO, like I said before, the 5 volts, which we don't need to connect because it can get its power elsewhere. These two are blank right here. There's nothing. and then ground. And you also notice I don't have the ground because we already have ground over here. They're both connected, so the one ground is sufficient. And then last but not least, the TDI, which is yellow. And there you go. So basically you have 5 connections from the FTDI programmer. Just follow this simple color coordinated pinout thing here that I created, and you are good to go. So that pretty much wraps up that. So what we're going to do is we're going to hook the card up itself to the FTDI programmer. I'll show you how that's done, and we'll come back to Windows here and execute the program command and see how well that actually will go. It should go fine. I'm really hoping it should. Anyway, enough of the rambling. I will be back very shortly.
Okay. I'm not sure how well this is going to show up on camera, but we are now on the JTAG_Xilinx, in other words, the Xilinx JTAG header, and we're going to be programming the Xilinx chip, which is located right here. This is the boot ROM that we'll be dealing with later with the ADF file, but anyways. So the header is hooked up, and all these, like I showed you in the previous image, these have all been verified to be the correct pinouts and from the programmer. So this is the FTDI programmer, the color-coded end, of course. The USB end is on the other side of the cable. So on the bottom row here, we have, as illustrated before, the orange wire, followed by the green, followed by the brown, followed by the yellow. And the only wire that's on the top row here is the ground, the black wire, so that's on pin 1. And it corresponds to the silk screen, which is slightly out of focus on the board because that's the way manual focus I should say, works. But yeah, it all corresponds to the silk screen right here. So what we're going to do is we're going to hook up the other end to the PC, hook this thing up to the power supply, and we'll go from there. I will be right back. Okay, everything looks good. The JTAG header there for the Xilinx chip is populated properly with the wires I showed you previously. We've got the USB connection to the PC on the other end of the cable, the FTDI Xilinx programmer, and of course we have the power supply right there connected to the floppy port type connector on the card. And we should be pretty much good to go. As a precaution, just to be on the safe side, I removed the compact flash card. If you have an MSATA card, maybe it'd be a good idea to take that off the back as well. Yeah, it's up to you. It's better to be safe than sorry. So hopefully, we're going to do the smoke test here. If I hooked everything up correctly, we should get lots of, we should be greeted, I should say, with lots of LED lights. So here we go. 1, 2, 3, on. Ta-da! So that's a good sign. So it actually turned on. None of the fuses looks like they have been triggered because they're all lit, and we're good to go. So I'm going to go to back to the Windows PC and load up the command prompt, and we're going to try to program this. Yes, and we shall see what happens. I will be right back.
Okay, we've returned to the Windows desktop, the much improved Amiga version, so to speak. Yes, if only. But yes, so the first thing we need to do is open a command prompt. So I'm going to click on start typing in the word command, and I only get in 3 letters, and that's good enough because it knows what I want. And you want to run as administrator. That way you get full access to the files that we need. Put this up here. And what we're going to do now is we're going to open up the folder from previous where the firmware is hiding. Go into firmware, enter Xilinx, and there we go. There's the C3S prog.exe file, the JED file that we need to flash, 009, and of course the commands. So if I open the commands folder that I showed you previously that we can copy and paste, I can't just do this right now, because if I try to copy and paste this, it's going to give me an error. It's not going to find this program because we're in the wrong directory. We're currently in the System32 folder. So one of the quickest ways to get to that is just go up to the address bar here of the folder that we just opened, and just right click on it and select copy address as text. And then I'm going to go over here, and then I'm going to right click. There we go. So once I'm in the window, right-clicked, good to go. But I cannot hit enter right now because this is Windows is going to think this is a command. There's no such thing as a Xilinx command. That's a folder. So what I need to do is just type in cd, change directory, put a space in there, and that hit enter. And there we go. So as you can see, we are now in the folder. Now it will accept this command. Now bear with me here, sometimes I have issues trying to copy and paste this in here, so sometimes it'll act like I didn't do anything because the window's not highlighted. So let's see if I get this right this time. So I'm going to select copy, click in here, and then I'm going to right click. And there we go. So all I have to do now is hit enter, and let's see what happens. If there's any issues, we'll know because we'll get an error right away. And that's good. It's communicating. Right now it's programming sectors. And it doesn't take too long, about 10 seconds or so. Yeah, pretty much. Yeah, about 10.9 seconds it took. So it basically said success, it verified, no errors, and it verified even quicker, like a quarter of a second. It had no retries, so we're good to go. So 009 of the firmware should be flashed. Excellent. So the proof, as they say, is in the pudding, whatever flavor you want, I guess. So we're going to put this back into the Amiga 2000 and use the map ROM tool. First of all, hopefully it boots, and then use the map ROM tool to confirm the version that has been flashed. And then we can try the ADF, the boot ROM flash, and see if that takes as well. Exciting times, my friend. Exciting times. Yes, we are now at the Amiga 2000 workbench. So it appears that the firmware flash was successful, or at least if it wasn't, it didn't destroy anything. So let us see what version we're actually at. So directory opus, no, not that. How about the Amiga shell? We'll open up the shell and we'll type in map ROM, the command, and status to show us the status of the card. And hit enter. And there we go. And yes, success. We are at firmware version 0009, or version 9 if you want to call it that. I will put a link for the map ROM function as well. This is the latest update that will exploit all the features that this card has to offer. And you can also see that I have the IDE wait states to speed up my compact flash access, set to 2 from the default of 8. Now it won't survive reboots when you set it, so you need to put it in your startup sequence or user startup sequence. And it's pretty easy, because in my case, if I go into directory opus and I click on edit startup, it's right here. So I added it right below set patch, so it seems to work just fine there, which isn't a bad thing, I guess. And yeah, so every time you reboot the computer, it'll be initialized, and it gives me about 3 roughly megabytes per second speed increase. So that's all you have to do with that. But that's it. So yeah, we are running at the firmware 009. So the firmware flash was successful. So now what we're going to try to do is update the LIDE device. Now I had issues earlier in this video. I had to retake this section because the audio quality was hideous and it was not very easy to repair. So I was at version 40.6. I flashed it to 40.7, but we will go to 40.8, which was that pre-release developer version. So I'll show you how that's done. But first thing, to check what we're currently at, just go into sysinfo, and we're going to go into devices up here. And then you have LIDE, and yes, we are indeed at 40.7. And like I said previously, it was 40.6, but we're at 40.7. I'm going to show you how that we're going to upgrade the LIDE device. And out of curiosity, let's see what the speed is with this version. So DH0, do a quick disk speed test. Yep, about 8 megabytes per second. You can run it a few times; it'll fluctuate a bit. But we're sitting around 8 megabytes per second, which is not too shabby, really. So that is that. So I will show you how we can create the floppy disk using track disk to boot off of it and upgrade the LIDE ROM to version 40.8. Okay. So all we have to do is go back to directory opus here. I already downloaded the images I needed and put it into a folder right here. So it's on the workbench, or the work partition. So we have the live update 40.7 and then the dev version. The dev version, this is, if I can stop doing that, it's 40.8. So that is what we want, and like I said, if you have a GoTech, you can just copy this directly to your USB stick and then have the GoTech boot off of it just select it in its menu system. But in our case, I'm going to go old school because I like floppy disks and I have functioning floppy drives. So what more could you ask for? So there's a program you can get off AmiNet called TrackSaver. You can literally search it on AmiNet for that name. It will come up. So we're going to click on that. And there is the interface for it. So we're going to select DF0 because that's the one we're going to use. And we need to select the file. So I'm going to drag the work partition here, and it's in downloads, just like before, LIDE. So this is one we want. Click OK. Now at this point, make sure that you actually have DF0 selected, because if you select one of your partitions, boot or otherwise, on like on a compact flash card or hard drive, it will make a mess of things. So be very careful. Now it will warn you, but you can still override it. But anyway, what we need to do is file to disk. If you go disk to file, you'd be taking the contents and turning it into an ADF. We actually want to make the ADF into a floppy. So we got DF0 selected, and we got the ADF file we need, so just file to disk. Click on that. So it is warning you that everything will be destroyed. And you click OK, and that's it. And then you wait for about 1 minute and 15 seconds for that to complete. So now it's writing the ADF image to an actual floppy. So I will join you when this is about to complete. And we're almost at the end of this. So the disk image is almost complete. And that is that. And if you're curious what's actually on this, if I go into directory opus, which I still have open here, and you go to DF0, there's the contents, there's the boot ROM itself, the flash tools, and of course the startup sequence, which automates the whole process, basically has the command line and the options to flash the ROM. And like I said, the beauty of the firmware 009 is now you can do this from the Amiga itself. You don't have to worry about using a programmer and removing the chip from the socket. So that's a bonus in itself. Yep. So what we're going to do is we're going to try the update process. What you need to do is disable the auto boot on the back of the card, the toggle switch. It's right below the 68,000 mode. And that'll basically disable the boot ROM so it can actually be flashed by this utility. So we will do that right now, and I will join you when the boot process begins. Okay, the selector switch has been established, and now we're booting directly off the floppy with the boot ROM disabled. And so far so good. And I just have to answer yes to this. And fingers crossed. Erasing the flash. And then writing the ROM and verifying it is done. It's pretty quick. It's like 32 kilobytes or something like that, so it's pretty fast. So just press return to reboot. Well, in this case, I have to turn the auto boot back on, so I'm just going to power off the computer, enable the auto boot, and I'll join you on the desktop when I return. So it appears we've made it to the workbench successfully. So the flash took for the boot ROM, the LIDE device. Let's see if we actually were upgraded to version 40.8. So back to sysinfo, back to devices, and LIDE, and yes, indeed, we are at 40.8. So let's see if we actually have any speed differences as well. I think last time we were at 40.7, we were at 8 megabytes per second, thereabouts. Let's go to drives, DH0, and do a speed test. And there we are. 8.6, we'll run it again, and it's sitting around 8.6. So we actually gained about 0.6 megabytes per second. If you're going to notice that, probably not, but it's it's a nice speed increase and cost absolutely nothing. So it's a bonus, I guess. Take what you can. So we'll get out of this. I don't think it resolved the issue, but if I go back into system, and remember I did a cold reboot because I had to put the system back into auto boot. If I go back into mounter, yes, the CD-ROM does not show up, just a compact flash card. So what I'm going to do, just to a proof of concept, which I know, but to show you guys, I'm going to do a soft reboot, and I will join you at that time, and with a bit of luck, you'll see that my DVD-ROM will show up. So I've returned from a soft reboot, and let's see if the DVD-ROM has magically appeared. And yes, magic has occurred. And it, like I said, it's just a cold reboot. It doesn't seem to work, but you can do a warm power cycle, whatever. It shows up every time. So I think what I'll do is I'll contact the developers and mention the issue I'm having and the configuration. Currently, the way the DVD-ROM is hooked up, like for my situation, it's using the SATA port. I think it has the same issue with the IDE header as well, and hopefully they can resolve the issue. But it's not a deal breaker. It's no big deal. I just I want to have use of the DVD-ROM. I just have to do a 3-finger salute, warm power recycle, and away you go. Yeah, that's it. So if you follow the instructions in this video, you'll be able to flash your Dicke Olga 68030 card. You can also do the boot ROM update as well. And that's it. And I hope this was helpful. But as always, thank you for watching.